What is this? Oh, I have two circuits here. First, let's take a look with the circuit. Push the button, it's on, push on, push on, push on. This is a transistor switch powered by my 5 volts here. This one is 12 volts, this one is 5 volts. See? And the circuit is here. Transistor, power supply 5 volts, LED with the series resistance, base resistor, push button, and pull down resistor here. So the transistor is in logic 0. It's because the push button is open. If you push the button, current flows here, also here, here, and here. Seems that this LED is not lighting because we have a pull down resistor here, putting the transistor in logic 0. There's your layout here, and let's take a look at the other circuit, this one. It seems that this is my older project, transistor logic gates buffer. Also the same circuit with my new circuit there. Also the collector side, diode and the resistor, base resistor, push button switch, and the difference is this 12 volts power supply. But since there is no pull down resistor here, that will cause this kind of dilemma. LED is turning on without pushing the button, making this transistor in a floating state. Why? Current flows here, 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 and here goes down here. Is which this push button is still open, but still the current flows here, goes here, here to the ground, making the LED light small current. That's why this LED is not so much bright. When you push the button, see, it's light, but still there's a little current that flows here at the LED because there's no pull down resistor here. Unlike here, this is transistor also as a switch or transistor logic gate known as buffer gate. See, with a pull down resistor here, this is a modified circuit of that transistor logic gate buffer. There's a pull down resistor here of 500 ohms, 100 ohms also is good. With that kind of resistor, there's no oscillating current, or they call it the floating state of the transistor here, putting this transistor in 0 state, input 0 or logic 0, since the push button is open. Here, putting the resistor here, transistor in the floating state because there's no pull down resistor here. Current flows here, 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 there. See the current? See the difference? Only the pull down resistor and double power supply here. So this one is defective. This is the new and modified version with pull down resistor. See the difference here? Push the button here, lighting, push the button here, lighting, but still the LED here is turned on with a little current, dim light here, powered by 12 volt supply. This one is by 5 volt supply at the top. Almost functioning the same as a switch or transistor logic gate buffer gate with with a difference of no pull down resistor here, and we have pull down resistor here. See the circuit, and see the circuit here, almost the same, but still there's no pull down resistor here. That's why it's causing this kind of circuit, floating state of a transistor, sometimes called leakage current flowing here, or reverse voltage. The transistor didn't know what its state could be, 0 or 1, because of this push button. There's a floating state because of push button. Okay, layout here. This is in my old project, and this one is my new project. So that's the difference between the two, and I therefore conclude that we need a pull down resistor with that kind of design, or else the transistor will put into a floating state because of the switch button, or the transistor is hanging. So, see? Okay, thank you.